part of running a mixed media or mixed modal way of accessing the information. So welcome to our Numicon Spotlight on Maths session that we're going to run tonight. One of the things that you will find out is that we start with a bit of information to begin with, and then we will go into an interactive phase because we feel that multisensory learning is best. So what that is when you are actually involved in the learning and the physical process of it, that touch, that do, that recognise, that respond, you're more likely to retain what you've done rather than just have it delivered to you. So we're going to put you through the whole experience of that. So as I mentioned, if you've just come in, we've got packs of the shapes here, and for those people watching from home, we will be selling these at $20 a pack, and we'd love to know your feedback, if that's too dear, if that's all of that, but unfortunately that's the price they have to be from the people that we buy them from. And what we hope to show you this evening is that the shapes in this little kit can be used for a lot of things. Even, for example, numbers to 326,492, you can still use these shapes to represent them. So they're multi-purpose through any age and stage of maths. So hopefully we can show you that. So hi, I'm Rebecca, if you don't know me, by the way, and this is Michelle.
Hancock, nice to meet you. If I haven't, I think most of you already know.
Okay, so as mentioned, this first part is about building our knowledge on what is Numicon and what does it mean here at Te Mata School and who's using it and all of those bits and pieces. And then we'll go into that interactive part halfway through as well. So we will do Q&A at the end, as well as give you some resource links and bits and pieces that you could access. But also, one of the things I would say is that if you do have a burning question, just ask, because actually it's hard to remember your burning questions sometimes after a long day at work or all those bits.
And often there's someone sitting right beside you who wants to know the same answer to the same question too.
So, as our junior school is currently using Numicon, the scope and sequence for mathematics to help guide us in making sure that we've got a well-balanced program. So we'll detail for you what that means, what that looks like, sounds like, etc. But first off, when going through any Numicon PD, they always talk to us about, well, what is maths? And maths is the exploration and use of patterns and relationships in quantities, space and time. Statistics is the exploration of use of patterns and relationships in data. Statistical analysis and data is huge moving forward in the mathematical curriculum and the refresh. So no longer do we talk about just maths, it's mathematics and statistics. Okay, so more what is maths? It's a great big conversation about relationships between quantities, events and things themselves. We have invented numbers and measures of many kinds to help develop our mathematical communicating, and mathematical communicating involves a great deal more than just words. So you can see actions, gestures, drawings, pictures, or you name it. So we talk about that multi-sensory. So for example, you'll see us do things like equals, plus. That movement actually helps ignite your brain synapses. And then here at Te Mata, as I mentioned before, we actually believe in running a balanced maths program. So as much as we're here to educate you about what Numicon is, Numicon's not our maths program solely. It's part of our maths program. Okay, it's a big chunk. But in year 0, year 1 and year 2, there are many other facets that make up that maths program, and it's got to be really balanced and rich. Now we've got a year 3 and 4 class trialling the use of Numicon as well, and they are loving all of it and the challenge that it offers in that environment. We've got groups of children across the school for different interventions or extension using Numicon as well. So it's not a resource that, for example, when I first came across it, I thought it was for children with special needs. And I thought that was the only reason Numicon, you would use Numicon. But it's actually a school-wide program. Okay, it goes from year 0 through to year 8. So here allows for maths dispositions, rich context, equipment and visuals, physical movement, and the promotion of communication skills. Now, you may have heard in the media that math statistics are not looking so good, and there's a lot of controversy around how that data was portrayed and all of those bits and pieces. If you want to chat more about that at the end, I can do that. But one of the things we just wanted to mention is we are going through a curriculum refresh at the moment, and the government has given us about 2 weeks to consult on the draft. And so, but the biggest aspects of it is, for example, we've read the whole document and analysed it already, and our staff will too. So around that purpose statement, it talks about symbolic reasoning, mastery, it talks about connection. So all of the things that we incorporate in our balanced math approach tie into this purpose, okay? And then under the government and our curriculum refresh, we have this rope with strands that include understand, which is patterns and variation, logic and reasoning, visualization and application. Know, that's your number, your algebra, your measurement, your geometry, your statistics, your probability. And then the do, where that's the practical stuff that you actually do, your investigations, you're representing situations, you're connecting situations, generalizing findings and exploring and justifying. So maths isn't just about knowing 5 times 5 or 3 plus 7 is 10. Maths is multi-complex, and so that's one of the reasons why we've opted to go towards Numicon in our junior school at this point in time, because it offers the detail that supports this and allows teachers to easily plan and easily teach to your children's needs.
Do you want to talk about the phases, sorry?
Oh, phases, yes, good point. So, you may have heard us, and we've just switched to in our reporting to you about curriculum levels. But the government is helping us to make another shift in the future towards what's called phases. And so phase 1 of the curriculum is years 0, year 1, year 2 and year 3. That's the foundation phase where they want children to have a really good base of literacy and numeracy. Okay. Then you've got phase 2, which is years 4, 5 and 6, where they're starting to apply what they've learned within the real world context. And then phase 3 is years 7 and 8, where they're embedding all of that and thinking globally. Now these phases also go on into high school as well until they reach NCEA. So we've got really, this is, for example, a 91-page document, bullet pointed what we actually specifically have to teach at each year, each age and stage. So if you're interested, we can chat about that. But that's not what we're here for.
Bit of light reading.
Yes.
Numicon follows a CPA approach, which is concrete, pictorial, abstract. So concrete is like the Numicon shapes themselves, or getting like 3 apples to show the number 3. Pictorial is when you can draw it in different ways, so in representation. So draw 3 apples, it's about talking about it as well, about auditory. And then moving on into the abstract, which is writing your numbers into sentences or equations. So if we have a look at the next slide, if you have a look on the left, the concrete is really big. So that's our first learners, our younger children. So they need a lot more hands-on. Then they have a little bit of pictorial and they're moving towards the abstract. But abstract is a lot more abstract, a bit more typical for them, so not as much of that. But our older learners, they a lot more experience at school, they have to have that concrete still, so the Numicon equipment is still there, but it's a lot smaller in this picture, and the abstract is a lot bigger. There are a lot more, they can get their maths book out and write equations in there. Yep.
And that kind of is in a way, like you think about that phase 1, that foundation of numeracy or maths, if you think about it, much more concrete in those first 3 years. And then as you move into that second phase, it's much more, you'll see much more of the abstract, because if we've got that really solid foundation and we can see what that number looks like as a base 10 representation, so hence the shapes you've got represent base 10. Now they can represent 1 being 0.1, or that can be be simply 1. Okay, so they can have many representations. That can be 10%, that can be 1/10. So it's actually, once they've got that understanding of base 10, they can then apply that as they progress through school. Okay, so what is Numicon? So Numicon is an approach to teaching maths that helps children to see connections between numbers. It comes out of an organisation called Oxford Owl Press. It's out of the UK. Okay, it's scientifically researched. It supports a child's early learning maths from year 0 through to year 8. It's also a multi-sensory way of learning, so through touch, feel, language, it touches on our senses. We don't encourage them to eat them though, so that's one we do miss. Physical resources like the colourful shapes that you've got in your hands are a really important part of the program, like Michelle touched on. That's that concrete aspect. And the holes in the shapes, so if you take one of them out and actually stick your fingers in them, that's actually really important. So when you're first learning to know that this is 5, poking your finger through and going 1, 2, 3, 4, 5 is actually really important. Pushing that into Play-Doh and making 5 little bumps come up is really important, because then they can actually physically count that. Now once that's mapped in, that's really powerful. So the tools represent numbers, and then students can develop mathematical concepts alongside. So we've got many resources. You might giggle at my shopping bag here, but one of our teacher aides works across our school, and it's full of Numicon resources. She trundles this around the school, goes from class to class, and takes them with her. So, and within that bag there's probably $2,000 worth of equipment just sitting in there. So as much as I said that's $20, because it's so specialised, and these are actually weighted, so that this 5 and another 5 weighs the same as the 10. That's why they can't be possibly on another website. So just so that you know. So we've got that. So therefore we're communicating mathematically, being active, illustrating, talking, we're generalising, and we're exploring relationships. Okay, so we wanted to show you a video, but we're only showing you
Numicon is an award-winning primary school maths resource which is made up of 3 main components: a teaching program, apparatus, and Numicon Online. It can be used as a complete program or alongside existing maths resources. To support these...
So we were actually only going to parlay you 18 seconds of the movie, because we feel if we go back to that very, very first point, and I won't talk over it.
Numicon is an award-winning primary school maths resource which is made...
I think that's the key part. It's won awards, it's researched, it's not something that we've picked up on a whim. So we've seen other schools have success with it, and internationally there is evidence of that, and we'll go into that a little bit too. So okay, we've got the shapes. So some of the things, we're just going to take you through some of the things that you might notice. So first off, when you're looking at your shapes 1 through to 10, does anyone notice anything about them?
They're all different colours.
They're different colours, awesome. Do you notice anything about the different colours? So if I look at 1, 3, 5, and I pull 7 and 9 together, and then if we go and we put these colours here together, are you starting to notice a pattern or a trend there? So you've got your warm colours and your odd numbers, and you've got your cool colours and your even numbers. So from early on we talk about odds and evens. So there's many different representations here that you can see. So that's just one example. For example, also when we talk about the numbers and we talk about, this is 1, this is 2, 1 more than 1 is 2, sorry. 1 more than 1 is 2, 1 more than 2 is 3, 1 more than 3 is 4, 1 more than 4 is 5. So we're always talking about that 1 more, 1 less. You know how we've talked about before and after for years. Before and after, it's the same principle. But what we're talking about it is a mathematical sense of 1 more. Anything else to add there, Michelle?
You think that's a really easy concept, but actually no, we have to actually specifically teach it. They don't understand otherwise.
And so the children are actually doing that active participation of doing that 1 more and 1 more and that touch and manipulation. So then we have, I'm of the generation that remembers Cuisinart rods from school. I may be a bit older than a few of you. So Cuisinart rods I just thought were for playing with when I was growing up. Really did not know what the purpose was. If you ask Sam Chatfield, the meter rollers, the wooden ones, you've probably all seen them in your education, and they've got a track through the middle. I had no idea that they were designed to actually hold the Cuisinart rods. Sam thought they were just for firing the Cuisinart rods across the classroom. So I mean, that's the thing. So we've all had different educational experiences. I thought these were for stacking and playing with towers. Sam thought they were for projectiling across the room. But when we use them at school, we explicitly teach with them. So all of the Cuisinart rods are exactly what we remember if you've experienced them yourselves. Okay, they are still the same colours. The ones, for example, here are also weighted so that they can be compared in pan balances for equality. So you'll notice here once again that patterning. So if you look at 5 and 10, you're yellow and orange. If you look at 3, 6, 9, you're cool colours. If you look at, for example, your ready colours, that is your 2, 4, 8. And so you're seeing those patterns and trends. Now, no one actually taught us these things when we were growing up with them. And then actually the grey and the black, does anyone know what they might be? Because it's 1 and 7. Any ideas? I had no idea. They're actually the prime numbers. So from this level, you can actually start to teach kids that they're the prime numbers because they're the only numbers that actually can't be grouped together. So they form their own group together because of the fact that they're not a multiple of or a factor of another.
What about 3?
3?
Isn't that a prime number?
3 is divisible. Yes, you're right. That's an exception. I love an exception. Thank you for yes, you are right. 3 is a prime. Okay, so we've got all of those things that we can teach as well. So, and
are they from the Cuisinart are obviously a little bit older? Are they from a different producer at first? Like,
you can use any Cuisinart rods. So if you've got them at home, absolutely use them. They've still got a purpose.
Part 2 to that is the colours. Can you expect like the colours to line up? Between the 2 different resources.
They're about the same. I know that, for example, in the traditional kits that I used back in the day, the one was white. So some of the ones might be white or a slight variance on colour like that. But it doesn't matter because we're not actually teaching the kids about the colour and the colour is one. We want them to be mapping on. So we talk a lot about, say, mapping on. So we have the special rulers, not for flying things across, but for actually sitting the shapes in, and so we map them on top like so that they can actually see that there are 2 ones that equal 2, and that's 2. So it's that process, so it doesn't matter about the colour or the
Sorry,
ones
I
you've
think
got.
between like Numicon and Cuisinart.
Oh, because they're completely different, yeah.
Yes.
Completely
I
different.
think it's you
Good
recognise the shape of it rather than the colour of it, and the rods are more abstract. If you had little lines on, it would make it more concrete, you know what I'm saying? So the dots make it more concrete, so it doesn't matter about the colour, it's just a more abstract tool. You remember the number by looking at the shape of it.
Right. So these are also representations of how the Numicon shapes can be used as well. So for example, different ways to show 8, different ways to show lots of different numbers because you're doing that mapping on. So you'd map the 5 and the 3 onto the 8 to see that that's the bond that makes it. And then once again, we've got the mapping on of the 8 with the 5 and the 3 and the Cuisinart rods. Then, for example, you can look at multiples and fractional thinking. So you can see that 12 24ths is actually equivalent to 1/2, because visually you can see that with the colour representations there. So it's being able to show different possibilities and different multiples and different factors. So they are used for multiplication, for division, for subtraction, for addition, for anything that you can think of mathematically, these shapes can be used for.
Very versatile. Oh, so it's one slide. The next one here is, this is what our teachers' planning looks like. So each of these little coloured strips across is around about a week's learning-ish. So they're made up of number and strand. So strand is things like weighing, measuring by length, all those sorts of things, time, money, all of these are covered within these topics. If you have a look, you'll see like it says milestone 1, 2, 3 as you're going across. Those are like, you have a little weekly units, and then you have a milestone check-in. So you have a little kōrero, a little talk with their children, and you figure out where their gaps are and how they're going with their learning. So little touch-ins, touch bases.
So we're regularly monitoring their progress and then knowing exactly what your children need to achieve or need support around as we go, versus say waiting for a test at mid-year or a test at end year. This is ongoing assessment in the minute.
And of course you're constantly assessing as you're teaching anyway. So this is like an overview of each of those weeks. This is what it looks like. So it's very explicit. It's very precise. Nothing's left to chance. So that's our planning, and it helps us with our assessment as well.
And I think you may have heard the government talking about we're moving towards testing twice a year around maths, reading and writing. But that is more so for years 3 through 6 for us. So if you're thinking about, well, what happens in year 0, year 1, year 2, these signposts, these milestones are really, really important, because we can't leave anything to chance. We can't wait till the end of term 1 to identify something. We need to be informing everyone as we go.
Absolutely. So this is a little case study that Numicon did. This is called a whisker graph. And if you have a look at the grey boxes, that's a control group. So that's children who've never used Numicon before. So that would be their average scores. And if you have a look at the blue ones were the results for the kids who actually use the Numicon equipment. So really successful. It's proven, it's been out there.
And the test that they used for this was the PAT test that we've all probably done in our lives, and that children still do. So it was the same assessment task, and this was the data that was produced. And you can argue statistical variance in cohort groups, but it's really interesting to see how an intervention or a specific way of teaching can actually benefit learners. I know, Michelle, you've commented about seeing progress that we've never seen before at year 0 or year 1 as a result of the scope and sequence, and it's really exciting from our point of view.
When the new curriculum refresh came out, they talked about lifting the year 1, what the expectations were, and I was going, ooh, because that's usually something we do at the end of year 2 or halfway through year 2, and you want us to do it at the end of year 1, that's a big ask. But now that we've got the Numicon equipment, we're finding that they can do it after like a term, maybe 2 terms at school, depending on how they go as a learner. So really exciting. That's something I thought would be a big challenge with the Numicon, has actually made it quite attainable for everybody, not just the bright learners.
So this is, I alluded to, we make equals with our body, we make plus with our body. This is an example of, equals to. So understanding what equals means is really important. Understanding what less than, greater than means. All of that language can't be left to chance. We've got to be really specific about it. So this is a little example from Brenda's classroom this morning, actually. She showed me and I was like, oh, I'm so going to use that. So, I'll move the kiddo, sorry. So what we've got here is our balance scales, and you would probably remember using pan balances when you were growing up. We're going to teach you how to make some tonight from paper cups and coat hangers. So, because what we figured is we can't show you things tonight that you don't have at home, so we wanted to make sure it was really practical, and this is not cheap. So, so Brenda, every morning, her class decides, well, what are they going to dance to? So they collect some statistical data and they do tally charts and they vote and all sorts of things. And it's either, I can't remember what each song was, the Wiggles or the Carrots, I can't remember. But what they do is they take that data, she writes it in the number sentence, she uses the Numicon shapes, she uses the representation of equals, which is from another resource that we marry in at year 0 called Number Blocks, and you may have seen that on Netflix. So we use that resource. This talks. Sorry. You may have seen that on Netflix. So Number Blocks is a really great show to have your kids watching, just to let you know. And so you've got the greater than, less than, and then what they do is actually enact that data afterwards, and they dance to the song that's got. But today it was equal, so I guess they dance to both. So that equivalence is really important. So as I mentioned, equivalence, so that equal value of, and that's from early on, 5 plus 5 is 10, to, for example, 12 24ths plus 12 24ths is 1, or they are equal in all of those elements. So it's understanding that it's not just about basic maths or foundation maths. And it can look very different. So one of the things that I think traditionally has been a misconception for kids is that equals is only seen like this. There's 2 things on this side and there's 1 on this side. Well, actually equivalence is 6 plus 4 equals 1 plus 3 plus 6 plus, and don't you love it? Nothing. Plus 0. So it's actually understanding that it doesn't have to be balanced on each side of the equals. Equals could be 6 plus 4 equals 2 times 5. So that equivalence and understanding that. So that's a really important aspect of maths. Okay, so we're into the interactive part. You've listened to us chat enough. If you've got any burning questions, we can answer them. So what we've done, we've got Maddie Bowler hiding over here as well. So, Rebecca, who is over here, is going to be walking around with the live streaming, asking us questions. So you might notice we're interacting with you as well as the live streaming. Now at our literacy event, we didn't stream the interactive part, so we're testing to see, and we'd love your feedback, whether it interfered or all those bits and pieces, because as we've said, we're just trying to figure out what works for today's parent, okay? So we've got Michelle's going to be on the other side, and we've got things like the pom-poms and the tongs, which you've got kitchen tongs at home, so you'll be able to see shapes, and then picture shapes and drawing shapes, and as I mentioned, the pan balance, how to make it out of a coat hanger and some cups, we'll show you that. Maddie's got greater than, equals, less than, and writing number sentences and activities around there. You may be wondering, well, how does this Numicon transfer through to beyond that foundation phase? So I will be doing multiplicative thinking, where we're doing multiplication with shapes, looking at numbers like 215,007, algorithms. Algorithms are back, in case you were one of those parents who kind of noticed that they dropped off for a while. The way we learnt maths is back, and so it dropped off for a while if you didn't know that, and all of those bits. So we're going to just let you explore and engage with that for about half an hour, and then we'll come back for Q&A. Sound good? Okay, but we will ask you to pack up your shapes for us, please, and leave them on your chair. And when you come back, you can have a look at them, and they might make more sense. So, okay, so all we ask is that you space out and spread out, and that way you can make the most of the experience.
Maybe start with me.
Beck, do you want to start with me?
Okay.
Hi, I'm Beck. Okay, so I'm going to show you. Now, Beck's got the phone on a tripod, so she's probably going to have to lean it up. So I'm going to start with this activity here. Hi, guys. If you want to start here, you're more than welcome to start here, but go on through. So what this one is, for example, here is we've got the algorithm. So traditionally we know that the algorithm might be written as 519 plus 463, and we go through that renaming process. Now for children, when they're learning this process, that would be what I would call the abstract version of going to it. So they need to start with the pictorial, or the concrete. And so you can see here we start with our ones, and then I realised when I join that together, well, that's actually a 10 and a 2. So I'm going to leave my 2 there, and that's going to transfer to here as a 1 more. So I'm going through that process of being able to see. Now I've got 8 there. Okay, and then when I join those two together, that makes 9. So I'm actually saying that that's 982. Okay, so that's that concrete aspect of it. So I can go through that process. So, for example, over here, we have got the multiplicative thinking. Okay, so this is the one where, imagine if you've only got the shapes at home, say one set of shapes and 1 7 and 1 6 and 1 4. So it's actually being able to draw around them. So I've pre-drawn a few, so I've done 3 times 3. And 2 times 7 and 3 times 6, and I've actually drawn the dots so that for those children who are struggling, they can still go 3, 4, 5, 6, 7, 8, 9. It's making it accessible at all levels. So this is that pictorial phase that we're talking about. Of course, in school they would have done lots of equipment. So, and then, for example, when I'm modelling it here, if I'm going 2 times 7, 2 lots of 7, I'm simply drawing around them so I can see. So 2 times 7 equals 14. So I can see that. Okay. So, and also you can do all sorts of things like 2 times 10 is 20, or I might go 4 times 10 is, so imagine having drawn them, is 40, so I'm actually getting to see them, touch them, feel them, and all of those bits and pieces. I might even go 2 times 10 plus 2 times 5, because that's equals what? So you can even go as complex as you want, so it's where it varies. Okay, so if we head on over here, what we have here is the likes of, for example, I've actually created the number 342,109. So I've done that with just the shapes that I've got. And then what I've done is write it in words. Of course, I'm a terrible speller, so I've used the internet to help me, or a printed out sheet. And then what I've done is I've expanded that so that I can see what it looks like. Now the importance of this is that the 0 has to hold the room. So even though there's not a shape there, we need to place the 0 to hold the room. So they can actually see that that's 300,000s, that's 4 10,000s, that's 2,000s, that's 100, no 10s and 9 ones. Okay, so you can make it any number to 1 million or to 10 or to 20. It depends on what number scope that the children are learning. Now, lucky last for me is befores and afters. So befores and afters, once again using the shapes, I have made an example. So what is the number that I have made, Mary? Ooh.
It looks like 600, and it looks like 17s there, so 672.
So 672, so then I'm going to make 673. Now imagine you've only got those shapes at home, you'd trace around them and do your dots, so you're helping that pictorial face. Okay. We love to have them organised in the container, and we don't cope when they're not organised. And then, for example, this is one I've preset where I've actually only put the after, so for them, and I've used the 0 to hold the room, so to hold that place. So that's 304. So what's the number before? Oh my goodness! I'm going to go. What's before 4? That's 3. I'm going to put my 0 to hold the room. and that's 303. So as simple as doing befores and afters at home is really beneficial because that's that foundation, and as children grow, you just make the numbers bigger. So, for example, in that first year, say year 2, year 1, need to know numbers to 100, okay? Year 2, we're up to like 1,000. And then and so forth. No, actually, sorry, year 3's 1,000 and 100 and so forth. So yeah, it's just that variance of numbers. Yeah, cool. But have a play if you want. Thanks.
So, less than and greater than, are they gone?
No, that's still
Which one's 8 and then what's the other one that's 8?
Yep, all good to go. Hi, I'm Michelle Hancock. I'm going to show you some ideas about how you can use Numicon at home. We have over here, you could use the tongs to be able to get the pom-poms and putting them onto the Numicon shape. That's really important because they need to be able to count 1 to 1. Can they count 8 as they put it down? Of 7 to say 1, and then as they put them on 2, 3, 4, 5, 6, 7. So 1 to 1. It's about instantly knowing that that is 8 as we're getting more familiar with equipment. And if we keep moving around, looking over here, you could use the Numicon shape. So you have the moving concrete pictorial abstract. You have the Numicon shape, 8. Then you can find 8 objects. You can use anything at home at all. And then put in the number 8 or the numeral 8, the more abstract beside it. So making the set like that, moving through. And if you move around more, come on the journey. This is quite a versatile wee thing. You can have like a picture of this train. It's about the children mapping them on, so they get in the shapes and they're matching it onto the same colour of in the picture, and then building it up to each of these dots is worth 10. So they could find out how much it is altogether. So we could do it in lots of different ways. We could find lots of 100s to make 100 plus 100 equals 200 altogether. We could use a number line. So we had a 20 for the 2, 30 for the 3, etc. until you get to the very end, 200. Or skip count in tens and point to each, 10, 20, 30, 40, 50, 60, all the way to the end. Or multiplicative thinking, so it's 20 times 10, so there's 20 circles, so I times by 10 and that's 200. So it has a lot of scope for further up as well. And our favourite here, we have just a coat hanger and some cups with little holes in to put the string on there. And if you hold it without holding it, so like balancing it on you, we can make, say, the number 8 in here. And we put a 3, that's going to hold. We put a 3, see how it's lying down, so this one's heavier than this one, heavier than, lighter than. We could put a 3 in here, it's still heavier than. What else could we be to make the 8? Let's put a 5 in, hopefully it works, here we go. So it's equivalent, equals to. And that's all from Michelle.
Are they the same shapes as what's the next one? Number locks. Are they like that? Are they like this for 3? Or are they like this for 3?
They are
Stacked.
I think it's stacked.
Yeah.
I actually like this better. This one was an even thing.
Yeah, it was really obvious.
Yeah, because you look at, if you do try and make 6 like this, how to make it? But if you made 5 high and then 1, it's not that obvious that it's an even number.
No, and it's really good because then you can go like this and say, oh, what's, like in year 2 we just covered it, what's an odd number and what's an odd number, what's an even number, what's an even number and an odd number, what's an odd number, even and even makes even, and even just getting, like it's that relationship of numbers that they pick up right from the get-go, that makes it easier for them. But yeah, feel free to have a play. Don't hit each other.
Yeah.
Use them properly. Oh, hi. Yes.
Okay, go.
Hi,
a midi bowler. Do you want to start there?
Yeah, sure.
So this is just one idea. How many ways can you make 10 using addition? So I was just saying to these guys, we teach them to do systematically in class. So they start with 9 and 1 make 10, and then they just write the number sentence alongside it, and then they just go through and 8 and 2 make 10, and then 7 and 3 and so on. So that's a nice easy one. It's over here. Just talking about the odds and evens. So odd number, oh, that's probably not the best one, and odd number has a little lumpy bumpy bit, even number doesn't. So we talk about how an odd number needs a little buddy to go with it, and an even number has the buddy. And we were saying in year 2 especially, going up, you can talk about how an odd number makes an even number, and so on. Even and odd make an odd, even and even make an even. So just some really good talk around that. Come back over here. You would have heard Bex talk a lot about the language of maths. So this one's just all around less than, bigger than, and just comparing what is bigger than and less than or equal to. So you could get your 4s out and say they are equal to each other. And just recognising, I talk about in my class that the crocodile eats the biggest number because he's the hungriest. So that's just a nice easy tip for you. So I'm talking to you. And then this last one is just their doubles. So you can say to them, oh, what's 3 and 3? And they can swat it just to practice their doubles. Have you been explained what mapping is? So you would hear Bex say mapping quite a few times. So we talk about if this, how do we know that's 3 and 3? So if you say to the kids, oh, what's double 3? And they say 6, you say, oh, prove it to me or map it for me. So then they get the 6 shapes and map it. We say map it, and so they put it over top, and that's their proof. As such, yeah, you could put numbers over top for them to be able to easily, because that's what the activity actually has, recognise them, and just lots of that basic facts type stuff is good for them. But yeah, I think that's me. Thank you. That's all good.
It's very easy for them to do on like the $2 shop or something like that. Those numbers. Oh, so it's complex. So the Numicon shape. So that's an 8, and you can get 8 objects.
Okay.
And then it's the new
Oh, I
so it's
see,
moving
yeah.
towards the abstract.
Yeah.
So it's getting that shift.
Yeah.
So it's their doubles.
8 plus double check.
So you can say to them, oh, what's 3 and 3, and they've got to swat it. Yeah. So you see on theirs, they have the numbers on it, so they don't have to recognise it. So practicing basic facts with it.
All done.
All shapes, isn't it?
Do you want to bring it in the store? Have you videoed all of this?
Yeah.
Perfect. Walk around the room with me while we're waiting for everyone to finish talking. Just going to have a look at some of the Numicon things that are in the classroom. If you have a look up here, we have the Numicon frieze. So it has number 0 all the way across to 20. See how the 11 is 10 and 1 more, the 12 is 10 and 2 more, 13 is 10 and 3 more, etc. all the way up. And of course we don't stop, we go right the way to the end, we don't stop at 20, because otherwise children stop at 20 and that's all they can count to, so we're always trying to add on to that, so 21, or we might stop at 19. So this number line finishes at 21.
Yes. Yeah, I remember using it. And I remember the ruler, I remember putting it down the ruler. Yeah.
About the early writing of number sentences. So they make up their own combinations. That's a Numicon 10. Have you seen the number sandwiches? Have a look, you're in for a treat. This is a number 10, so if we make a number 10 Numicon sandwich, we could get an 8, and 8 and what makes 10? We can see clearly it's the 2, so it's not about counting the shape, it's recognising instantly. So 8 and 2 makes 10. We could pick another one, so if we had 5, 5 and what? 5 and 5 instantly see the shape. So you keep stacking up the layers on the sandwich. We have 9, dropping them all. 9 and what makes 10? 9 and 1. Or 4, 4 and what? 4 and 6. And if we put the 10 back on top, that makes our number 10 Numicon sandwich. There we go. Just find out back once the video does come in.
Q&A.
Now we can do a Q&A. Have you pushed stop? Nope. Still going. I think we're still for the Q&A.
Yeah, totally. How much is a whole bit?
So that's about 130. So, and we can, if say you're a family that want to get a whole kit, we can help you source that because we can put in a bulk order. Often the most painful part I've discovered of ordering Numicon is paying for the freight. That, so what I'm trying, like Michelle knows, I'll often go, what else do we need?
Michelle asked for this.
And I'm like, no, I've got to bulk it in because it is the freight. So if you were someone who was interested in a whole set, just let us know and we can put in a bulk order and all of those bits. So I mean, this is a resource that has so many, you would have seen, so many different aspects. So this is when you're doing square numbers. Could you imagine 4 to the power of 4, 2 to the power of 2, all of those. They can also add in these. So it's specialised to that essence. So if you fall into the pit of the EduShop online shopping, you will see number lines, you will see, you name it. And what we actually did as a school, rather than buying like a resource, a starter kit, we talked to all the experts and we said, what do we need? Because we could have spent thousands that we didn't need. So we made sure that what we did get was really good. And we're optimistic that the government's going to help us fund more for the school next year. So, yeah.
Watch this space.
So any questions, any wonderings? And like you guys might have other questions afterwards. Anyone on the live feed can email us and ask questions. Oh, are they? Sorry, excuse me. So, that's a really good question. I can't specifically answer that because I've never actually Googled it. But I have known, so I've been working with it, like I mentioned, with children with special needs for about 12 years. And then when I was working, because I used to work at Clive as the DP for years, we went up to Tauranga and I saw it across a whole school and I was like, wow, my goodness, it was amazing. And kids were engaged and bouncing. So it's been around for a long time and it came out of the UK. So, yeah.
So you said it's just during school at the moment, right, and trialling
In year 3 and 4, yeah.
So what's, like, is the intention it will be
We, because
on trial, but
So we actually started to trial it last year before launching in with the junior school, because we're not the sort of school that just rolls something out because it looks pretty, so we'll take that. So with the year 3 and 4, we haven't reached that point of looking at the data analysis. So, and that might sound a bit, but it is about bang for buck. And we want to make sure we're investing in the right resource for the right age and stage. We know that the government's giving us a really clear guidelines around that foundation for years 0 through to 3. At the moment, we need to see the evidence that it works for that year 4 through to year 6 transition. And definitely I've seen a group working with decimals and percentages and fractions in year 3 and 4, because that is now the expectation that is taught at year 4, whereas in our old curriculum it was taught at year 7 and 8.
Oh, even later.
So the language of decimals is now coming in at year 4. There's a huge shift coming in maths language. So yeah.
At the moment then, year 3, you go
Yes.
to 4, so you're using it at 3 and you wouldn't be using it in year 4. Is there sort of a way of transitioning away from it?
So we're composite classes, so the year 3 and 4 trial is using it completely across year 3 and 4.
Yeah.
And that is very successful. So the way that, say for example, the government says to us we've all got to use a prime textbook, okay, because we actually haven't had that guidance from the government yet. Okay, so we're waiting for that in the next so many weeks. Numicon partners and marries with that beautifully. So if you can imagine in years 0, 1, 2 and 3, the Numicon equipment and prime can work together, because this is the materials that represent the numbers in a textbook. Okay, and what prime is a textbooks. Okay, and of course the scope and sequence, but they don't provide the equipment. But then you can imagine as you move into year 3 and 4, you might not be following the Numicon scope and sequence, but you can use the equipment to represent, because we need to make sure that our kids in year 2 are transitioning into an environment that they're supported in. So all of the classrooms are going to need to be rich in Numicon, because if that's their picture that they draw on, they need that scaffold. So that's up to us to make sure that we scaffold that through and resource that accordingly. So even if it is a textbook for something else, they'd still have those resources to support them. Great question. Okay, so like we said, we'd love to know what you think if this is something that you would be interested in purchasing. We had to buy, I think, how many sets? About 30? Because we're in the box. So we've got lots of them. And one of the wonderings that we were wondering is if it was an optional resource item for at the beginning of the year or throughout the year when parents can buy it. So we'd love to know if you think that's a good idea or a bad idea. You know, something great to have at home that you can just pull out to talk about. So what we will also do is put on our Friday memo this week these links here. So you've got page of Numicon shapes, for example, there. So you could actually don't have to buy them. You can just print them, cut them out, but of course they're not weighted. So but
not as easy to manipulate for little fingers.
Yeah, and because remember that importance of pushing it through Play-Doh and putting the fingers through it, and you can't trace around those ones.
But even picking them up off the table. With little fingers, it's tricky.
So we've got some YouTube clips as well that you can watch. We've got the Numicon at Home website page. There's actually a page to support families, and Numicon activities and partner videos. So we'll put that in the Friday memo so that you can click on those bits and pieces. But I mean, we've finished a little bit earlier, but we don't want to bore you to death. So, but we're happy to stay and talk math for as long as you want to.
Come and have another play if you missed out or want to have another.
Yeah, absolutely. So if you've got a burning question on that note, haere rā, live feed. Yeah. Has it stopped now, Sam?
No.
I'm still cringing at the thought that the literacy one's still floating around on our Facebook. Not as funny intend to see your teaching career evolve into live stream videos.